So at the end of the last video, we explained how Pythagoras concluded that the number that squares to be 2, like every other number, ought to be a nice fraction of whole numbers. Well, here's a theorem that says that it's not. Theorem: no fraction a over b can square to be 2. Well, proof by contradiction. Suppose there is some fraction, d, a over b, that squares to be 2. Well, proof by contradiction. You want to prove that something's wrong? We suppose the opposite of what we're trying to prove, and hopefully we'll come to some sort of problem. Well, if this really is just a normal fraction, a over b, then we can reduce it. So let's suppose that a over b is a reduced fraction. Fine. So, if d squares to be 2 and d is a over b, then a over b squares to be 2. And a over b times a over b is just a squared over b squared. So a squared over b squared is 2. Now we take that a squared over b squared equals 2, and we multiply both sides by b squared. A squared over b squared times b squared equals 2 times b squared. We can cancel out the b squareds, and we're left with a squared equals 2b squared. Hey, this a squared is 2 times an integer, right? A and b are integers. When you multiply an integer by itself, you get another integer. This means, by definition, that a squared is an even number. And by that lemma that I said we were going to use in a little bit, if a squared is an even number, then a is an even number. So a is, by definition, 2 times something, 2 times n. Okay, well now let's take this a squared equals 2b squared and replace the a with the 2n. No problem there. So 2n squared equals 2b squared. And what does it mean to square 2n? It means 2n times 2n is 2b squared, and 2n times 2n is 4n squared. Now you take this 4n squared equals 2b squared, and you divide both sides by 2, like that. Now, these 2's cancel out, and 4 divided by 2 is 2, so you're left with 2n squared equals b squared. What's wrong with that? Well, this means that b squared is an even number. It's 2 times some integer, and therefore b is an even number by our lemma. Wait a second. We said that a over b was a reduced fraction, completely reduced. There's nothing that you can reduce any further, but now we've just said that the numerator a and the denominator b are both even numbers. And if they're both even numbers, then a over b can be reduced by dividing top and bottom by 2. This is a contradiction. We have a fraction that is reduced and not reduced at the same time. Something has gone wrong. How do we resolve this contradiction? We went wrong at the very start when we said that this number d, with d squared equal to 2, could be a rational number, a over b. Conclusion: no rational number a over b can square to be 2. Quod erat demonstratum.